Hello and welcome to a new chapter, number 25, episode 16. In this episode, we are going to cover some important topics to review when you are facing a performance problem, like wait stat or resource consumption. Other topic I think that is more important is how SQL Server manage all these processes using source scheduler. My name is José Manuel Jurado. I am a escalation engineer working in Microsoft and subject matter expert in this technology. What is the agenda for these sessions? The first thing is we are going to cover a little bit of theory. We have many documentation about it, but we need to specify the key points that we need to understand how SQL Server works using the SQL OS. After it, we are going to cover several main actors or components that we need to know when we are managing or check a performance cases like tags, workers, schedulers, or CPU. Finally, we are going to cover what that means wait stats and the reason that we have this. We are going to review several demos. We are going to show you several demos about different topics discussed previously. And we are going to share with you several links related with the information that we have. Well, let's get started. But how to check a performance issue with one database? Well, you know that we discussed previously multiple things about it, but I think that we need to review two main things. The first thing is resource consumption. So because it's important to know if the main consumption is CPU, DataIO, or LogIO. After it, we are going to review the wait stats, because the wait stats means what is waiting SQL Server to execute the workload. As we mentioned before, what is the key components that we need to review when we are talking about resource consumption? Well, the first thing is to review if we have high CPU. High CPU means that, for example, SQL Server needs time in order to convert the data when you have conversion implicit, or for example, when SQL Server needs to read more data because we don't have indexes that is covering the filter that we are using, or for example, we have a lot of workers or a lot of processes working in parallel, or we have a lot of single process running at the same time. We have a bad execution plan based on the statistics, parameter sniffing, etc. Other element that we need to review is about when you have high DataIO. When you have DataIO, normally also means that SQL Server is reading too much data, that also most probably in creating and missing indexes, we are going to reduce this. Also, could be that you are reading too much information or too much data, or you don't have enough memory to manage all the queries. Remember that SQL Server is using buffer IO. If this data is not in buffer IO, needs to go or needs to retrieve the data from the storage, bring the data to the memory, around the process. Or finally, it's when you have high LogIO. That means that you have a lot of operations, updating data, writing data to the transaction log. Okay. The other element or the other topic that we need to review is the wait stats. We have plenty of wait stats in SQL DB or in SQL Server, okay, that represent what is waiting for, as we mentioned, SQL Server for different parts, component, operators, etc. So for that reason, before to review the wait stats, we need to review how SQL Server works, okay? The first thing is SQL Server is multi-thread applications. It's running in parallel with multiple threads, multiple CPUs. It's running in cooperative mode. That means that it's using the workers, multiple workers at the same time to run one specific query. Before SQL Server 2005, SQL Server works in the multi-threads on Windows, and after it, we introduced one new element that is called SQL OS. It's an operating system with a new design to scheduling the different process, the different tasks, in order to run much better this scheduling process. So every time that a query is submitted, SQL Server needs to prepare a task to execute with operations to be done. Okay, so for the reason, SQL Server, in order to execute all this process, SQL Server has at least one thing that is called workers. SQL Server has a special queue of workers depending on the number of vCores that you have in order to run this process. In this process, when we have a worker, this process will reassign a worker. And we have here the first thing that we need to review is the following. So right now we have three main weight stats about the workers: running, runnable, and suspended. Running means that this worker is running, is doing something, so it's using the CPU. Runnable means that the worker is pending to have a CPU available in order to run. So if you see that you have a huge amount of runnable process, most probably means that your SQL Server is not enough to manage because they need more CPU. And also we have suspended. Suspended means that SQL Server or this worker is waiting for other resources, for example, obtain the data from I/O, etc. Once SQL Server assign a worker, is going to, as we mentioned before, is going to have a CPU to schedule to run this query and execute part of the operator that we need to execute. Let's say table scan, shorted data, etc. So at the end, as we mentioned, at comparative mode is SQL Server. When you need to run this one query, we are going to split the operations among the workers that we have, okay, in order to execute the query as soon as possible. We reached the point that is key to understand how SQL Server works and the way it starts, etc. So right now, suppose that you have a worker, and suppose that this worker needs to read data. Okay, it's not in the memory. So SQL Server needs to request a worker in order to read the data from the I/O. Or for example, a worker needs to acquire an shared log in order to read the data, but other process already holds the as exclusive log. So all these such of things is the weight stats. So, or in these situations, when SQL Server, when the worker needs to wait, have to wait, it's called wait type. Okay, so it's what is waiting for. What is the concept? Let's say log, let's say assign or I/O, let's say source schedule yield, etc. Okay, for example, we need to read the data, PAGEOLATCH. We need to block the data, log m char or any others. Other topic that is very important is how much time the worker needs to wait. That is called wait time. So for the reason we have right now, the first concept is the wait type, what is waiting for. Wait time is what is waiting, how much time is waiting. Okay. In overall, all these concepts, how many wait types that we have, the time is called wait statistics. this set of metrics. Okay, so we have also a special scenario that when we need to run the query in parallel. So in the beginning, all the queries is going to use, let's say, is going to run in serial, but sometimes SQL Server thinks that, hey, I need to run this in parallel. So for this reason, SQL Server is going to create from one task multiple tasks. These tasks will be assigned to different workers, and for every workers, they need to run several parts or distribution of the data. For example, if we need to read millions of rows, SQL Server will, if we have the opportunity to run in parallel, is going to read from, let's say, from the first 5 millions is going to read in these tags, from 5 until from between 5 and 10 millions we are going to read this data, etc. You can start to imagine what happened when the max degree of parallelism is not correctly configured. Yes, it's going to monopolize all the CPU. Yeah, for the reason when we have a performance problem and all of them is waiting for the CX packet or all this wait stat, much probably it's a good opportunity to review the max degree of parallelism and try to adapt this value from the best balanced number that we could see. So after this discussion, to try to summarize the situation it's a good point to review the weight stats, because at the end we are going to see how much time is taking all the operations that SQL Server is doing. Of course, it's not a bad to have weight stats or high numbers, because at the end means that SQL Server is working. Depending of the weight types, during the query execution could show us the bottlenecks that we need to review the query. If you have high weight types, or for example, or you have weight counts that we are going to show you in the next slides, in the next demo, can indicate also how many query interactions that you have. It's very important to remark this, because, for example, suppose that you have PAGEOLATCH. The PAGEOLATCH is very high, but you wait just only one time. Makes not sense to, because much probably it's because you run a query that is reading a huge amount of data. But what happens if I have weight type, for example, PAGEOLATCH, but my weight counts, let's say, how many operations were waiting for this time in average, for example, it's relevant because means that you have a huge amount of operations that was needed to wait to complete this scenario. Okay, so what is the basic idea? What is the concept that is the takeaway for this theory? It's so stop when you have a performance problem, wait that review the weight stats and review what is waiting for. Okay, because depending on this wait force, SQL Server could point us in the directions to take in order to review or to fix this performance problem.
Okay, the first approach when we have a performance problem, I used to perform two operations. First is try to run these resource stats that we could see all the information about CPU, DataIO, local write, etc., and the weight stats. Okay, so this is the two DMVs that is possible, as we mentioned, what is waiting for and what is the resource consumption. Okay, so I have a small script here that I'm going to reproduce several scenarios. Basically, I'm going to run 8 process to run 100 operations per process running random. Random means that I'm going to use part of the LogIO, CPU, CXPACKET, well, this is. So it's running right now, and as you could see, right now we could see here, most probably in a couple of seconds, yeah, we saw the CPU that this operation is taken right now are taking. Most probably in another 15 seconds. We are going to see CPU, DataIO, LogIO is 100% of the time, memory, etc. So beside this is what is waiting for the different SQL Server. Well, if I run this query, we saw or we see the different times that we mentioned before in a previous slide is how much time is waiting in a accumulated way, how many operations were waiting for this wait type, what was the maximum time, and the signal time. But this is a accumulated way that's starting from when you restart the SQL Server. Okay, so in this case, I'm going to clean everything to start from the beginning. Okay, of course, that don't do it in production environment, but if needed, do it. But it's important because when you run this, all the statistics is going to start from the beginning. So we are going to start from 0. So right now, if I run the query, I'm going to see different scenarios about how much time it's taking, the operations that it's doing, etc. Other scenario, other query that I found that is very interesting beside other that we have waiting tags for the database, etc., that we could use, it's also per session, what are the different wait types that we have per session. Okay, for example, we have here that the session number 53 is waiting for several aspects about async LogIO, networking, or it's session number 61. It's waiting. It seems that it's waiting for the I/O or other scenarios that we could have about other such of things in this case, etc.
Before before going to the next demo, just only to summarize how SQL Server works. Basically, remember that when we submit a query, this query will be, SQL Server is going to check the syntax and compile the query and provide the execution plan to be executed. Well, for me, how I understood how SQL Server works. Well, basically, I split into things. I'm going to run part of the query in parallel or not. If not, I'm going to, we are going to choose right now to execute, we are going to assign a new tags, okay, when I submit the query. This tags is going to assign one worker, and this worker is going to assign a CPU to execute. So it's going to run in serial, let's say to serialize the process, okay? But of course that it's not, if I need to use other worker, for example, the worker I finished the process and I need to run other operation, let's say short after the table scan, most probably we could use other worker, okay? And also, what happens if the query is going to run in parallel? Well, if we are going to run in parallel, SQL Server, instead to create just only one task, is going to create multiple tasks depending how many processes SQL Server things to run in parallel. Okay, we are going to have multiple tags. These tags is going to assign to the different workers, and these different workers is going to assign or to find what is the CPU. So right now you can imagine what happens SQL Server, right? If I have if all the queries running in parallel is I don't have a very right number or very balanced number in terms of parallel, we could monopolize all the workers. If I have multiple requests and I don't have too much CPU to manage all this, most probably all the workers will be runnable. If I have a problem in terms of I/O or I demanding or I don't have too much data, most probably all the workers will be in suspended mode waiting for the async operations, etc.
Well, we have all the details. We know the wait stat, but let's try to also review the query that we have to review other aspects about the wait stat, the performance, etc. First of all, I would like to share several DMVs that is very important about the request. As you can see in this request, you can see right now several processes that is running in background. Okay, it's completely normal that we have several processes running in the background because it's different activities that the SQL Server it's running to obtain or to manage several details. Right now, we have any other process that, as you can see, is running bulk insert, selects, etc. And other thing that it's about how many CPUs that we have in my database. Well, if you run this DFV, you could see how many that you have. All of them that is visible online will be that is possible to use by your database. Okay, so we have a special thing here that is called DAG. It's that is when something is happening, database is not responding. You could connect to the database and kill the session that is offending or it's doing some it's blocking everything. For example, we could see other that is called task that right now it's running the status, IO, the worker assigned to this process, etc. We could see the workers. The workers is another point about his status, his preemptive, it's waiting for IO, how much time, the affinity, all the details about these workers, right? So I'm not going to go to explain all the details because we need hours about it. But for example, pending on IO, it means that the time, how many times that SQL this worker needs for the IO. Um, I don't know, any other tips about the process, etc. And finally, we could see about the resources that we mentioned about the CPU usage that we have right now. As you could you could see all the details running this process. So I'm going to stop the process that we have right now and in random way, and I would like to show you what happened with the different scenarios that we have. I'm going to kill all the sessions that we have right now. Um, well, all the sessions were killed. I'm going to run, for example, the first scenario. Again, we are going to run 8 process running a loop 100 operations, and we are going, for example, the first scenario about the LogIO. When I run this process, I'm going to run the query that we have here. The first thing we could see here, it's we're increasing a lot the terms of the log write. Right now we have 100. If I run this query, we see right now we have at least 4 workers or requests that is inserted the data. This is the scheduler or the CPU that we are using. This is a session that we are using, and this is the weighted type that we have. Is load rate governor means that you are reaching the maximum capacity in terms of transaction log. We have the query. We have the address of the worker, etc. So also here, most probably, we could we are able to see the total elapsed time, the time that is taking the query, what it's waiting for, etc. Other scenario that I would like to share with you is, for example, let's try to kill data sessions and the same and, for example, use CPU. So right now we have eight processes running that they need just only CPU. So if I run again this query, in this query you can see that we have at least 8 vCores. More of them, all of them is running in different vCores. We could see the select CPU time that is using, the weighted type when you're using CPU. If I run right now the resource stats, we saw high CPU but 0 in terms of LogIO. It's complete normal about it. All the data is in the memory, so we don't need anything about IO percentage. So other scenario that we could run, it's for example when I need when I have a lot of contention in my 10db. Right now we are using a lot the data, the 10db. So right now the CPU is very low. Let's see if we have more information. But even when we have the CPU is very low, well, it's not 100% of the CPU, but you can see one specific wait stats that is waiting for a PAGELATCH. That means that it's reaching one specific page in the database, in the 10db database, in order to update the metadata. Okay, as for the reason you could see here, what is waiting for about the resource, waiting for the database number 2 is 10db, the file number 1, and the page. If I run again the query, we are going to see the same scenario with other situations, etc. Finally, other scenarios that we could use. It's, for example, let's see, 1 second. It's about CXPACKET. Okay, so suppose the following scenario. We are using 8 processes. This every 8 process connecting to database is going to use in parallel 8 vCores that we have at the maximum CPU that we have in this database. You can imagine what happened. Most probably, one connection, one process that we have from my application is going to monopolize, is going to use all the CPU at the same time, right? So what happened with the second one? What happened with the third one? Okay, SQL Server needs to manage all this work, and sometimes this when you have CXPACKET or you have any other weight stats that means that the CPU could be very high, okay, but the scenario that you have here, it's taking too much time or in a different way. So, for example, right now, as you can see here, right now we have many of tags. Okay, these tags we have a worker assigned for this connection. Okay, this connection right now is using multiple tags in this part. For this, we have different schedulers that the worker is trying to use 1, 0, 1, 2, 3, 4, 5, and 6. Okay. Um, this, as you could see, other thing is, as we mentioned, this is the primary tags, and this is the child tags that we have for this process that is running parallel. We saw the select. We could see also the query that we're running. If I run again the query, most probably I'm going to see CXPACKET somewhere. Okay, wait type, etc. So you can imagine what happened. Most probably several could be possible to run in the scheduler number one, but the rest uh, we need to wait to complete other ones for the reason when we have an incorrect value for the backstop that we have in our database here. It's possible that you are going to have several problems. For the reason we need to try to find balance what is the best choice for the executions about the parallelism. Parallelism is perfect, so it's a good choice. But the problem is when you have a huge amount of queries running in parallel. So for the reason, try to find the balance. It's quite difficult, and it's a learning process in order to find what is the correct balance. For example, if you're running just only reading data, in this case, it's good to have for example, the maximum, for example, depending on the max stop. But if you're using OLTP, that is, you're not reading too much data, but it's just for insert, select, insert, update, etc. Depending on the situation, could be 2 or 1, could be one idea. Okay. And finally, let me just sorry to give the last scenario, to share with you the last scenario about the login. Okay, so as we mentioned in the previous slides, if I run again the process using login, when this process is running right now, all the requests will wait for to have the resource in order to access the data and to modify the data. Right? If I run this query, you are going to see that one is running, the rest is suspended because they are waiting for from the log from the log of the query. Okay, so as you can see, we have intended exclusive, we have exclusive in the weight stats. Right now we have we finish, other one is running, other one is waiting for to run, etc. So it's other point that the weight stat could show us that this query is running, but the rest is waiting for. So it's very important to see what is the reason that is waiting. For example, this query, as far I know, is running, it's updating all the table. Most probably we have a log escalation, table log escalation. Okay, that there is not possible to do anything until the query would finish. So we have the wait resource, etc. So for the reason, as we mentioned, the combination about consumption resources, about the wait stats, it's very important to determine what is the problem and what is the performance problem that we have. For example, we have log right now, the CPU is not high, but the log is high because we are doing a lot of updates. So also, if I review, if I run again the query, for example, let's see, one of them that will be running. 1 second. Yes, this one is a session number 17. If I go here and specify here 17, we could see right now the wait type is this time. Other wait step that is running. It's clear that we are going to use write log because we are logging the data and we are updating the data. We are using log buffer because at the end we need to write the data also in the memory. We need CPU, it's of scheduled GL. If needed, we need to bring the data from the storage to the memory, but most probably all the data is in the memory for the reason we have here nothing. Okay, and there is no need to request memory because all the data is in the memory. So, and then with this, you could see what happened. You could understand what is your performance problem.
Well, you could find multiple things in this lesson learns. You know that we have one blog that you could find all the details about the errors, about best practice, etc. found in our well, thank you so much for attending these sessions. If you have any questions, doubts, etc., or you need more information, please, you could send me an email in this address.